Hey everyone, welcome to Stack Genius Coder YouTube channel. In this video, I'm going to make you understand the concept of insertion sort algorithm. Insertion sort is a simple sorting algorithm that gives the output of final sorted array. It works by iterating over the arrays. Basically, it starts from the second index and inserting each element into its correct position. Okay, let's take a look on the insertion sort. So this is our array. So these are the iteration 1, iteration 2, iteration 3. So let's start from the first iteration. So the insertion sort, we will start from the second element. So 2 is the value. We will compare with the previous value. So 8 is greater than 2. So we will move the 8 to the right side and we will place the 2 in the first place. In the second iteration, the key value is 4. We will compare with the previous element. So 8 is greater than 4. So we will move 8 to the next position and we will compare with 2. So 2 is not greater than 4. So we will place the 4 into the first place. In third iteration, the value is 9. So the 9 is greater than 8. So we won't move anything. So we will keep as it is. This iteration, the value is 3. So 9 is greater than 3, so that we will move value to 1 by 1. So finally we will find out the correct position for 3. So the iteration will follow the same thing. Finally we will get the sorted array. Okay, let's achieve this insertion sort in a programming way. This is our unsorted array which we are going to sort. The first step of insertion sort is we need to start from the second elements. We need to iterate rest of the elements. Okay, to do this we can do the for loop. We need to start from the second elements. In array perspective, that is a 1 row and the rest of the elements, so that len of a or on. Now I'm going to keep the current value in key property. Now we need to have one more property to compare with previous elements. Let's say for example the starting element is 2. Okay, so that time the key element will be 2. We need to compare with the previous element. To get a previous index, we have to subtract I value with -1. Now we need to do one more while loop to compare with the previous element. Here what we are doing, we are comparing with the key value with the previous value. For example, 2 is our key value and 8 is our previous value. So the ARR of I is greater than key value, so that the loop, the condition is satisfied, so that we need to move this greater value to the right side. Okay, so that is what we are doing, this line. Suppose the iteration is continuing for element 4. Previously we have 2 elements, so we need to reduce j value as well. So to do this, j minus equal to 1. Once the j value is below 0, so that time we need to exit this while loop. We need to add one more condition over here, j value. Okay, so the loop will continue only if the j value is greater than or equal to 0. So finally we need to assign key value to j plus 1. Okay, let's, for example, suppose the iteration is continuing for 4, the key value is 4 and the I minus 1. So the starting point of the j value element is 2. When we're doing the while loop, so the condition will be not satisfied. Okay, because of the 2 is not greater than 4. So that time what it will do, it will come over here without executing this while condition, and it will directly assign the key value to the current position. So when we comparing with this element, so 8 is greater than 4, so that time we need to move over here. Okay, so likewise this array will work. Okay, and finally once the loop is end, all the unsorted array will be sorted. Let me print it out, the output value ARR. Okay, done. Oops, something looks like wrong. 2233. Oops, sorry. So we should not assign, already we have taken the key value, right? So it should not be ARR of I, it should be ARR J. Okay, let me run again. Yeah, we got the output. So if you can see 2 3 4 6 8 9, so this is our sorted array. So this insertion sort algorithm technique is only work for the small data set. It is not efficient for large data set. And the time complexity for this insertion sort algorithm is O of n square. Okay, So this is the time complexity. N means size of the element which we are passing, and time complexity means how much time the algorithm is taking to run. That's it. Thank you for watching this video. If you like this video, please raise a thumbs up and subscribe our YouTube channel. I will see you on next video. Thank you.